Hi, welcome. This is Mr. Bouchard here, and this is the Notes for Science 8 on metric measurements. Today we're going to go over how do we measure using the metric system in science and what are the different units, etc. You guys will be working with. Also in this video will be scientific notation. I will be doing a separate video on converting metric measurements, which will be also attached to this note set, but it will be slightly separate from that. Okay, first thing, measurements in science are an observation. So remember, whenever you make a measurement, you are making an observation with better accuracy or precision. It's a description using numbers. Remember in science class also that we do not just write numbers, we also have to have units of measurement. They should be rounded to the nearest tenth for the most part, because that's what we're accurate to usually. So one place after the decimal. So when you get a big number or a big decimal number, just round to the nearest tenth. Has units, so example, 35.68 grams, you're going to write that as 35.7 grams. And you can actually use the abbreviation. So we can write it (35.7) and then lowercase g is the actual abbreviation for grams. Now, if you don't know the abbreviation, you can always just write out the words instead. So either way, just make sure you do label your answers. That's an important thing, because we need to know what you're measuring in science. All right, next, metric system is used in science, also in countries outside of the United States. We're one of the few countries that are lagging behind in this. We haven't converted fully to the metric system. There are some things that are in metric though. We buy soda in liters as an example. So we have some things that are converted already, but most of our things, gallons, inches, feet, miles, we're still in the old system. So based on the unit 10, number 10, that's why the metric system is a lot easier to deal with. We're going to see when we do metric conversions how much easier it is to go between them than it is in the English system. Inches to feet, you guys know, there's 12 inches in a foot. So you have to remember those conversions or type them in the computer to figure them out. Whereas metric system, you don't need to. Metric prefixes are used on the numbers, so centi, milli, kilo. All right, they all are the different metric units or quantities, basically. All right, so I'll just write down a few of them. So again, we have centi, milli, kilo, deci. All right, we'll have to eventually learn all those. We're going to use something called the ladder method to change between them and move the decimal around to change your units, basically. All right, common measurements. So throughout science, we're going to use different measurements in different situations. So time is a period in which something happens. We just simply use a stopwatch or a clock to measure this, and units could be seconds, minutes, hours. There's also milliseconds. All right, if you're a track person, you always go down to really precise answers with that. All right, but that's time. We also have temperature, which is the average motion of the molecules in an object. So temperature, when we're cold, that means molecules are hitting our skin less often each second. That's why we feel cold. If we're hot, that's because the molecules are bouncing around fast and hitting our skin more often. And that's why we feel warm. Temperature is used, you got to use a thermometer, measure it. And we're going to be using Celsius in the metric system, but also in this country we use Fahrenheit. We still use it in weather forecasting, so we will still look at Fahrenheit, even though it is an English unit. Length is the distance between 2 points. So obviously you'll measure from a starting point to an ending point. Ruler, meter stick, tape measures, different things that we can use to measure, depending on the size of the object, obviously. Meters, centimeters, millimeters are going to be the most common used. We also use kilometers. When we do mapping, we might also use feet and miles, because again, in this country, we still have our maps in those things, those units. So we'll be looking at examples of that with topographic maps. Okay, next we have mass. That's the amount of matter in the object, the amount of particles in the object. A balance is used to measure it, and that looks like this down below. So this is a balance, a triple beam balance. And the reason why they say that, because there's 3 sets of weights. We always start with the biggest first. If it tips over, then you move that one back and then go to the second one. All right, and you keep doing that until you get it, till the balance mark is reached. And that's when you get your answer. And you got to read all digits, starting with the hundreds, tens, and then the ones. And then all the way down to the tenth of a digit, if you can. Grams and kilograms are units. When you're using the balance, it's going to be in grams. All right, volume. That's the amount of space the object takes up. To measure it, we're going to use graduated cylinders for liquids. And remember, you've got to read the bottom of the meniscus curve on that, because the water clings to the side of that. So I'll show examples of that eventually. A ruler could be used for rectangular solids, and then in math class you might have learned a formula. Volume equals length times width times height. So you're just going to multiply that and get your answer. All right, for irregular shaped objects, such as a rock or even a spear, you could use it for. Water displacement is a good technique. And what you do, you put water in a graduated cylinder. You fill it up to whatever amount of volume. You drop the object in, and then the water level will raise by the amount of volume that the object applies on it. And so basically you just subtract how much water was initial in there from the final, basically, and that's how you get your volume. So we'll do examples of that. Usually liters, centimeters cubed, all right, because remember, volume is a 3-dimensional thing. That's why it's centimeters cubed. If you do area in math, it will be centimeters squared instead. Also, milliliters is another one we use. So again, that's the smaller unit. Liters are the bigger unit. Okay, also, I want to talk about today is scientific notation. This could be a little tricky. This is a way to actually express a number easily in science class, especially if you're using small or large numbers. You'll be also doing this in math class, so it's good to know this. Used to write small number in large numbers in a simple form. The first digit must be a number between 1 and 10. Numbers greater than 1, you're going to use a positive exponent. So 2.3 times 10 to the 4 as an example. All right, we'll expand that out in a moment. Numbers less than 1, meaning a decimal, are going to use negative exponents. So 4.5 times 10 to the 3. All right, so I'll do a couple examples up on the board. So the first one, 2.3 times 10 to the 4, what is that written out? So all you have to do is move the decimal point 4 places from where it is currently. So 1, 2, 3, 4. Rewrite your number. Get rid of the decimal, and that's your answer. So in this case, it's 23,000. Okay, so again, you're going to move the decimal place 1, 2, 3, 4. All right, and that basically is the final spot. Remember, always count where the decimal place starts. It's not the amount of zeros. A lot of people think that initially, and you might have learned that in the past, but that's not the case with these numbers. And also the negative exponents, you're going to move the other way. So I'm going to give some room, because we're going to move the decimal the other way. So 4.5, and I'm going to move it 1, 2, 3 places to the left, and put my decimal in my new spot. So the answer really is 0.0045. All right, and then the last one, if you want to move to scientific notation, you start with the decimal at the end, and then you're going to count the amount of jumps to get to that number. So to get a 2-digit number, all right, or a number between 1 and 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that was 9 total jumps. So my answer for this is 2.3 times 10 to the 9. All right, so that's what you have to do for those numbers. All right, if I get a decimal one, then you're going to count the jumps to get between the 7 and the 4, because again, you have to have a number between 1 and 10. 1, 2, 3, 4, 5, 6, 7, 8. So that was 8 jumps total I counted. So it's going to be 7.4 times 10 to the negative 8. All right, so again, the difference between that, so 7.4 times 10 to the minus 8, that's going to be a decimal number. If you have a positive exponent, it's a big number. So make sure you know that difference. Okay, I am going to stop there because we're just going to stop with the scientific notation on this video. The next video we look at is going to be on converting units in the metric system. I thank you guys for tuning in.